Given question, determine the range of force P so that the system is in equilibrium. Coefficient of friction between plane and the block is equal to 0.3.
Let us understand given system. Block of weight 500 Newton is placed on inclined surface which is making an angle of 70 degree with horizontal. We have to find out range of effort P applied to the block so that the system is in equilibrium. We will give the small displacement to the block. So there are two cases. In first case, we will give the displacement delta S is in upward direction, and in second case we will give displacement is in downward direction. We have to show weight 500 Newton which will act in vertically downward direction passing through center of the block. We have to show the direction of applied effort P. So this effort is applied through the rope connected to the block, and this rope is parallel to the inclined surface. So we have to show the direction of P is in the upward direction and this P is parallel to the inclined surface. Block slides on this inclined surface. So the displacement delta S is also parallel to the inclined surface. So we will show the first case delta S is in the upward direction. We have to show the line parallel to the inclined surface, and in second case we have to show delta S is in the downward direction. Now we will draw the free body diagram. When the block slides on this inclined surface, then the frictional force develops. Now this frictional force is in the opposite direction to the displacement. So in first case we have to show frictional force in the downward direction, and this frictional force is parallel to the inclined surface. So we will show here one line parallel to the inclined surface, and this frictional force is F. Now in second case, frictional force in the opposite direction of delta S, that is in the upward direction. So here is F. Now block is in contact with inclined surface, so there is normal reaction N. So this normal reaction N is perpendicular to the inclined surface. So we will draw one perpendicular line, and this N is passing through the center of the block. Now in this case also we have to draw one perpendicular line, and this is the normal reaction N. Now if we observe this P, then frictional force F and delta S, which are parallel to the inclined surface, and then this N is perpendicular to the inclined surface. If we observe this 500 Newton which is in vertically downward direction, so we will resolve this 500 Newton into two components. One component is parallel to the inclined surface and second component is perpendicular to the inclined surface. So how to show this? So we will take one line with parallel to the inclined surface, and here we will show this component. Now we will take second line parallel to this N, and we will show here one other component. Now in the same way we will show the component for the 500 Newton. Now how to decide the angle? If we observe this inclined surface and horizontal line making an angle 70 degree. For this horizontal line, this is the vertical line perpendicular to the horizontal, and this inclined surface is having, this is the perpendicular line. So angle in between these two perpendicular lines also makes the same angle 70 degree. So we can say that this is the angle theta. Now in the same way we will show here the angle theta. So this component is nearby to angle theta, so we can say that it is 500 cos of theta, and this away from angle theta, so it is 500 sin of theta. So here also it is 500 sin of theta, and here is 500 cos of theta. Now we will find out the value of this frictional force. Now this frictional force F is equal to mu into N, where mu is coefficient of friction and it is equal to 0.3. Now how to find out this N? So we will consider the equilibrium of the system. Now we can say that summation of forces perpendicular to the inclined surface is equal to 0. So in this whole diagram, how many forces perpendicular to the inclined surface? So here it is 500 cos theta and this N. Both are in opposite direction. So we can say that 500 cos theta is equal to N. So I will write here 500 cos of 70 is equal to N. So if we solve this, then we will get N is equal to 171. So F is equal to mu, that is 0.3 into 171. So F is equal to 51.30 Newton. So this is the value of F we have to use in the calculation part. Now we will consider the first case when delta S is in upward direction. Now here the sign convention is the important part. So the forces which are in upward direction parallel to the inclined surface, we will take positive sign. So I will mention here. So we have to mention the direction of forces. So here the forces parallel to the inclined surface but in upward direction take positive sign. And at the same time forces in the downward direction which are parallel to the inclined surface, we have to take negative sign. So this sign convention is important. Now the components which are perpendicular to the inclined surface, now that for that component displacement is equal to 0. So we will mention the displacement. So this component is perpendicular to the inclined surface. So at this component delta S, because there is no any movement along the perpendicular direction. This movement is taking place along the inclined surface only. So we will show here the displacement is 0. So for N is also displacement is 0. So we will show the displacement 0. Now when we apply virtual work method, then we have to take force multiplied by displacement. So we have to take summation of forces multiplied by with the small displacement is equal to 0. So when we apply virtual work method, then we will take the first force. So first force is this 500 sine of theta, that is 500 sine of 70. So if we observe it's a direction, so it is in the downward direction. So minus 500 sine 70 multiplied by delta S. Now delta S is having direction upward, so we have to take positive sign. So minus 500 sine 70 into delta S. Then next force is F. So F is also in downward direction. So here we have to take negative sign. Minus 51.30 because F is equal to 51.30 multiplied by delta S. So delta S is in upward direction. So we have to take with positive delta S. Now P. So P is in upward direction. So plus P into delta S is equal to 0. Now from this equation we will take delta S as a common term. This delta S is not equal to 0. We can transfer to the right hand side and it will be getting cancelled. So the remaining answer is minus 469 minus 51.30 plus P is equal to 0. Therefore P is equal to 521.14 Newton. So this is the value of P is given. That means when this applied effort P is equal to 521.14 Newton, then only there is the small displacement in the block. Now we will move to the second case when delta S is in the downward direction. Now in this case also we will take force multiplied by displacement. So first this force 500 sine theta, that is 500 sine 70. So direction is downward, so take minus 500 sine 70 into delta S. Direction is downward, so minus delta S. Then F is in the upward direction, so plus 51.30 into minus delta S. And then P. So P into delta S. So here direction is upward. So plus P into minus delta S is equal to 0. Now from this equation take minus delta S as a common term and transfer to the right hand side. So remaining answer is minus 469 plus 51.30 plus P is equal to 0. So when P is equal to 417.7 Newton, then there is the small displacement of the block in the downward direction. So this is the range of P when system is in equilibrium. So range of P is in between 417.7 Newton to 521.14 Newton.